Example 2, solving equations containing two radicals. So this time we're going to have a radical on both sides. So our first one over here, our very first thing we need to do is get rid of the radical. That's the same as step 2 above, so whether it's a square or a cube, once again, look at the index. Okay, so remember, if we don't see a number here, what number is here? It is a 2. So to get rid of the 2, we need to take both sides and square it. Okay, so that means now the square root and the square go away on both sides. But that 2 also goes to that 5, as well as that square root there. So because this crosses out over here, it's just 35x. But now I have to square my 5, which is 25. And I need to take this out of the square root here, so it's just x plus 2. And my next step is to solve. So if I need to simplify it, in this case I need to distribute. So 35x equals, and that's 25x plus 50. And now we need to subtract the 25, because these both have an x and the 50 doesn't. So 35 minus 25 is 10, so 10x equals, this cancels, and we're left with 50. To solve for x, we need to divide by 10. So x equals 5. We need to do the same thing on b. So get rid of the radical. In this case, it is a cubed. So to get rid of a cube root, we need to take the cube. So this 3 cancels with this 3, and we're left with x plus 6. But this 3 goes with the 2, and then that 3, so it cancels that 3. But 2 cubed, 2 times 2 times 2 is 8. Parentheses, and then since this cancels, just what's inside. And now we solve. So we take the 8 and distribute. So x plus 6 equals 8x minus 1. Let us minus our x because this one's bigger. So 6 equals 7x minus 1. Oh, that is not a 1. That should have been an 8. Because 8 times 1 is 8. So that's an 8. So now when we move that 8, we have to add it. So 6 plus 8 is 14. Equals that 7x, and this one away. Divide by 7, and x equals 2. Try this one on your own.